So hello once again, and today we are talking about this. We are talking about plasticity, and plasticity as a concept in philosophy, psychoanalysis, and neuroscience. So as one of the concepts that brings together in a fruitful way might be a point of connection between philosophy, psychoanalysis, and neuroscience. And Freud's, the guiding intention of Freud theory of his progenital development of a child was quite revolutionary for his time. And why? Because he indicated direct connection between the development of individual and specific ways of human interaction with the external environment. And by showing this physiological process of human development, by trying to figure out the way how human being develops by interacting with environment, Freud, what he did, he withdrew individual development from the metaphysical scope. He was trying to show the physical way, scientific in his view, way how human being develops. And in Leonardo da Vinci and Memory from His Childhood, in Freud's work, he formulates the fundamental principles of his theory. And he claims that our aim remains that of demonstrating the connection along the path of libidinal activity between external events and personal reactions. So, tracing sexuality for him, for Freud, it was libidinal plasticity. That is the sexuality that was the domain where human being change, within which human being changes, and through their interaction with external world. So tracing sexuality through childhood and adulthood, Freud derived, we can say, material ontology, not a metaphysical one. According to him, for Freud, there is no essence in human being and no strictly prescribed ways of their development. So it's rather carried out through the external influences and personal reactions. So how human being develops, how they change it depends on interaction with external world and how they react on this external world. And it can be said that Freud's concept of libidinal activity anticipated modern neurobiological concept of brain plasticity, because in accordance with this concept of brain plasticity, brain is not a collection of fixed genetically programmed ways of development, but it's plastic. It develops in a plastic way through interaction with environment and through the process of learning. So it's changeability, and individual experience their surrounding and their own activities, their experience leave an imprint on her neuronal pathways and have the capacity to shape her brain. So this is what Freud anticipated when he was talking about libidinal plasticity. So for him, libido is something that is plastic. It changes. It's not. There are no prescribed way that we follow when we develop. We follow certain ways that depend on our interaction with environment and our experience. This was Freud's way to interpret human changeability in a material way, not in a physical way. That there are some prescribed ways how we develop. And in his article, Freud Returns, Mark Solms claimed that he found a parallel between contemporary neuroscience and psychoanalysis, and he claimed that what Freud did is that he discovered and elaborated under the name of libido, or something that neuroscience rediscovered. And he claims that, Mark Solms claims that, I will show you. So, yeah, that the seeking system regulated by the neurotransmitter dopamine. And so it underlies our need to explore and the pleasure that we feel when we satisfy this need. So in Solm's view, Freud's libido is a sexual drive, is something that later was rediscovered by neuroscience with this pleasure-seeking mechanism that energizes our goal-directed actions. But I don't really think this analogy is correct, because what I think the better thing, the better way to draw this analogy, but it's certainly, this analogy is certainly better than presuppose that like popular psychology does, that what Freud discovered by claiming that the main thing about human being is libido, is that it's some sexual activity. This one is better, but still it's better to claim that what Freud anticipated with this concept of libido, of changeability of human being, is it's very changeability, the way we change on a physical level, and that we don't, and that so the plasticity of the brain, the very changeability of the brain. Just neuroscience formulates it in a from a different perspective, but what Freud discovered is this material way, the materiality of changeability of human beings. So what he anticipated, it's not pleasure-seeking mechanism, but rather the changeability of the radical changeability of what is human being, of the process of how we develop. That it depends on our experience, on that we don't strictly follow some prescribed by nature or by some other forces, spiritual forces. We don't, in our development, we don't follow those ways, some ways that are prescribed by nature or by some external metaphysical forces, but it depends, it's changeability within us, it's material, and it somehow depends on learning and on our reactions. So all these things. And so now let's see the point, discussion points. Something that we can discuss is what are possible fruitful points of collaboration or exchange between neuroscience and philosophy. And it's not necessary to talk about it right now, just those discussion points. We can discuss it at the end of our meeting, or we can discuss it at the end of our class, or, well, now, or you can post your blog entries discussing some of them that you're really interested in. So if you have any ideas about this right now, you want to talk about it, we can. Otherwise, we'll proceed to the next topic. So now let's talk about brain plasticity and the way it functions in neuroscience. So the contemporary neurobiological concept of plasticity designates, when we talk about brain plasticity, we talk about neurons, and the main basic object of study of neurobiology, as we discussed already on our first meeting, are neurons. So those cells that brain consists of, the parts of the brain that brain consists of. And the human brain has approximately 100 billion neurons, so it's a lot. And neurons carry message through the electrochemical processes. To see how neurons carry those messages. They are electrically excitable cells that processes and transmits information through electrical and chemical signals. So neurons differ from other cells in the body because they have, let's see, let's take a look at neuron. Yeah, so this is neuron. I think all of you know. And neuron have special parts called dendrites, and axons, and cell body, soma, and like other cells, all of them have this cell body. But dendrites, what they do, they bring electrical signals to the cell body, and axons, they take information away. So from the cell body, and these signals between neurons occur via synapses. Synapses are special connections with other cells. That's how neurons connect with each other, and neurons connect to each other and form together neural networks. So neuron that emits an action potential is also said to fire. And the most striking manifestation of brain plasticity is capability of new experiences and learning to recognize neural pathways. And when we learn or memorize new information or we gain new experience, something occurs in our brain. So our brain changes. There is nothing that can happen to us. Nothing, we can't learn something or we can't feel something. Nothing happens to us without our brains being changed. So we learn and memorize new information, and that makes an imprint on our brain that consists of neurons, and this changes these neural connections is what we call neuroplasticity. So the classical illustration of neuroplasticity is a lamp of clay. And the idea here is that we leave, by molding clay, we leave impression on it, and it changes. When we mold it, it changes from inside and it stays the same. So this is what brain plasticity means. It changes, something happens as a result of our actions, our experience, and it stays this way for a while. So our brain changes all the time. It has capability to modify itself, to adapt to our experience, to new experience, to environment. In accordance, it depends on our interaction with environment, and it changes, of course, including now when we talk. Just any new information you get, it changes your brain, and so your brain is never before as it's never same. It always changes, and this process of changeability of the brain called plasticity. So one more way to demonstrate it, it's to show you one of those illusions. This one is with a dog. So if you know this picture, there is a dog hiding in it. So if you can't see a dog, I will teach you to see the dog. Here is the dog's ear and legs. So now the funny thing is, once you know, you learn to recognize the dog. Your brain is never going to be same again, because you have this new knowledge, and wherever you see this picture again, you will know how to recognize the dog. You'll automatically recognize the dog on this picture. So it's quite violent process going on in your brain, because I showed you the dog, and now you can't get rid of this. You can't undo it. So your brain changed forever. It just changed your brain forever. So, and discussion point, something that we can discuss is, yes, what do you think is the connection between plasticity and libido, and is it worth looking for parallels between Freud and modern neuroscience? We can discuss it now or at the end, and probably it's preferable, because so just of course we can show that, like Malabou does, Malabou does, she tried to connect psychoanalysis and idea of Freud's plasticity of libido and neuroscientific concept of plasticity. But on the other hand, maybe is it reasonable to do that? Because those new concepts, it's questionable for me, because those new concepts, they designate quite different reality. And is it in what way it might be fruitful to come back to Freud within this new type of designation of reality? Maybe we shouldn't do it. And if we do, we might think, what is the connection between plasticity, neuronal plasticity, and libido? Or maybe there is no point to do it. Just Freud was part of the history, and now what we're talking, it's something else. And what we can do, we can just compare them probably, and see the way it was before and the way it is now. So if you have some ideas, you can talk now or later. So we can proceed and talk about three types of neuronal of brain plasticity. Yes, three types of brain plasticity. In the book, What Should We Do with Our Brain? You have PDF in your folder with readings. Malabou claims she follows quite trying to connect neuroscience with philosophy and build some philosophy on the basis of neuroscience and this concept of plasticity. She follows quite widespread tendency to distinguish between three types of plasticity. There is developmental brain plasticity, modulational plasticity, and reparative brain plasticity. So according to her, let's see her passage. She claims that there are three levels of plasticity. The modeling of neuronal connections, this is developmental plasticity in the embryo and the child. The modification of neuronal connection, the plasticity of synaptic modulation throughout life, and the capacity to repair. This is post-lesional plasticity. The way she explains what plasticity is. She explains that plasticity in the nervous system means an alternation in structure of function brought about by development, experience, or injury. So it corresponds to those three types of plasticity, with development, experience, and injury. This distinction is not perfect, and we will see. I'll explain later why I think so. That and those the very designation of these types is not perfect as well. So first type of plasticity is developmental plasticity. It's the one brought about by development. So what at stake here is initial formation of the brain. And that is the formation of the brain starting from the stage of embryo, and then it continues after birth, this initial level of plasticity. And it's traditionally claimed that it develops till about 15 years. And the initial formation of the brain is associated with neuronal genesis. So genesis, it's new cell nerves, new neurons are born, So on this initial stage, the brain grows in its mass, starts to be bigger, the new cells are born and synapses are formed, those connections between neurons, and some other secondary changes occur. And it is claimed that this process is strictly genetically determined, or more genetically determined than other types of plasticity. So for these reasons, General, for example, claimed that from the point of view of the genesis, all human brains resemble each other because it's predetermined process. It does not depend so on experience, on interaction with environment. This is why all brains resemble each other more or less on this stage. So those changes, those modifications are strictly more or less programmed and follow the pre-established plan of the development of brain anatomy. So if the pre-established way we talk here about, so if it's if it's pre-established, there is some pre-established way of how brain develops. Why do we talk about plasticity here if it's pre-established? And there's a very important concept for me, and not just me, but is apoptosis. I love it a lot. Yes, this is apoptosis. The picture shows you the neuron that goes through the process of apoptosis. And apoptosis means a neuronal death, suicide of neural cells. It's very important process in neuronal development of neurons, and it accompanies neuronal genesis. So not just in a embryo brain, and later on, not just new neuronal cells are born, but at the same time, simultaneously, lots of them die. So lots of them go through the process of apoptosis. This is the pre-programmed neuronal, not only neuronal, but in this case, when we're talking about brain plasticity, it's pre-programmed neuronal cell suicide. So apoptosis is programmed cell death. It is a part of implementation of the genetic program. It's supposed to be this way. They're supposed to die. So there are too many neurons born in the brain of the embryo, like excess of new neurons. It's over the amount of them, and a significant amount of them dies. This is the process of natural selection. There's lots of them are born and lots of them die at the same time. So in human brain, apoptosis is most intensive in the stage of embryo, and then it's very intensive till 6-4 months of baby's life, and then it continues in adults, but at a much slower pace. So apoptosis plays a major role in shaping and sculpturing embryos' brain, and it's not only about neurons. Yeah, all the cells undergo almost this process. So apoptosis is under general genetic control, but activation of it sometimes regulates by environment causes. So it is now well known that cell death is a fundamental aspect of development of almost all organisms. So it's not just generation of new cells. What brain is formed, the process that brain neuronal cells undergo when they are formed, when the brain is formed, it's not only generation of new cells, but also this process of apoptosis. It's same crucially important. So this process, in case of neurons, designates that brain is not fully formed at birth, but it has this mechanism to form itself. It forms itself through this kind of destruction, not only genesis, but there is other process apart from genesis, which is not least important, and it's destructive process here of nerve cells dying away. And let me show you a quote. So Malabou claimed that cell death is a tool allowing the embryo to work out its form and its becoming by eliminative procedure that allies it with culture. So this is why we claim that this is plasticity, because the cell not just follow the pre-established genetic way of how everything shall develop the way it has to develop according to genetically predetermined program, but there is this process of that has this capability of to sculpture brain, and its destructive process of apoptosis. So now there is another process. It's called synaptic pruning, and Malabou doesn't talk about synaptic pruning, but I think it's also very important because it's also destructive. I love like destructive processes. So it's also a part of developmental plasticity, and synaptic pruning means that over the first few years of life, when the brain grows rapidly, as each neuron matures, it sends out lots of multiple branches, those axons, which send, I mentioned, and dendrites, which take part in the take information in. So it increases the number of synaptic connections and lays specific connections from neuron to neuron, the synapses. And at birth, each neuron in the cerebral cortex has, for example, approximately 2,500 synapses. And by the time infant is 2 or 3 years old, they have like 1,500 synapses per neuron. So this amount is about twice more than average adult brain. So then it gets 2 times less. So as we age, our connections are deleted. Yeah, and this process is called synaptic pruning. So not only cells, the whole cells, lots of cells die away, undergoing the process of apoptosis, but also all of our neurons have lots of dendrites, and then they form lots of synapses, but then lots of those synapses, they die away because they undergo, so it's too much, and then we grow and they got pruned, so deleted. So also undergo, not just new synapses are formed, but lots of them undergo synaptic pruning. So synaptic pruning eliminates weaker synaptic contacts, while stronger contacts, they remain and start to be stronger. So experience determine which connection will be straightened, which synapses will stay, and if we don't use some of the synapses, they undergo a process of elimination. And so there is this one more destructive process that is need to exist apart from the process of genesis that for our neuronal plasticity to function. And this synaptic pruning can already be considered not a developmental plasticity, but modulational plasticity. So the role of the surroundings starts to play a fundamental role within this modulational level of plasticity. And when the brain forms, it modifies as a result of interactions with the environment. And there is more space here for plasticity. It's not it's not predetermined by a genetical program, not to that extent as it was in embryo, but it depends quite a lot on environment, on interaction of environment, and it is itself the imprint of environment, the result of our interactions with environment. So it's something which is considered to be contrary to genetic, genetically predetermined program, because it doesn't depend on our experience and our interaction, and modulational plasticity depends on our interaction, on our experience, and this allows more plasticity. Modulational type of plasticity allows more plasticity. So two basic processes here are process of learning and memorizing. We learn, we memorize, and our neuronal pathways change. This is experience that that our brain undergoes, and it changes as a result of learning and memorizing. So now to explain what is currently known of the mechanism of learning and what underlies this principle, brain plasticity, the key concept here. Well, it's possible to distinguish three mechanisms underlying memory and learning. And the first possibility is formation of new cells. We know now that even in an adult brain, new cells are born, and so that when you learn something new, and new neurons might appear. And what else? But what else can change in the brain apart from formation of new synapses is formation of new synaptic, new neurons is formation of new synaptic connections. So when you learn something, new synaptic connections appear or get stronger, and those all are examples of structural changes, because there is a new structure, a new synapse, a new axon, new dendrite, so structural changes occur. Another type of possible changes is functional changes. And the idea here is that existing synapses that already exist, they get stronger or they get weaker. When we learn and when we try to memorize something, we have those synapses that connect neurons, the type of neurons connect, the way of neurons connect with each other. And those synapses, when we learn to code our new knowledge or new experience, they get, some of the synapses get stronger, and at the same time that some of the synapses get weaker. So concerning these functional changes, the fundamental law here is Hebb's law. Probably know about it. So Hebb's rule, at the end of 1930s, some experimental observation led to Hebb scientists to abandon rigid localization of circuits of memory, as it was believed that these circuits are rigid, they don't change. And he discovered that they changed, and he formulated the hypothesis about the capability of modifying neuronal connection during the activity of perception and learning. So when we perceive something, he discovered that when we perceive something, we learn something, those neuronal connections, they are not rigid, they change. And the capacity of synapses to modify as a result of this interaction of the process of learning, it was formulated in this Hebb's rule. And it's basically, it works in two ways. It works, the classical, this is the classical way of interpretation Hebb's rule, that neurons that wire together. That means that they, if we use some, well, I will explain in a minute. Just what else we have to know about this process is that what is happening is at the same time potentiate. There is a process that's called long-term potentiation and long-term depression, and both of them are very important. Long-term potentiation is a process of straightening of synapses based on recent patterns of activity. So these patterns of synaptic activity that results in a long-lasting increase in signal transmission between neurons, and the opposite of long-time potentiation, this increase of the straightening of certain synapse, is long-term depression, and it produces a long-lasting decrease opposite in synaptic connection. So in simple terms, this Hebb's rule is usually interpreted as, yes, as you saw, what wires together, and so if a certain he said that when an axon of one of the cells is near enough to excite the precise cell, or repeatedly and continuously takes part in firing it, this synapse start to be stronger. And this is basically how we now understand the process of changeability of neuronal pathways. So and it is first. So if one of the cells is continuously involved in activation of another cell, if this synapse is actualized, it starts to be stronger, and it grows. Its metabolic process change, and it keeps and the synaptic connection synapse gets stronger. So if it happens so that first cell, one of the cell activates, so that fires with the other cell, it means that the connection between them starts to be stronger. So they straighten the synapse between them. But at the same time, this is how we interpret usually Hebb's law, by explaining this process of long-term potentiation. But there is, what we have to remember here is, to me, it's very important that there is other process of long-term depression that so when some of the synapses get stronger, at the same time in our brain some of the synapses get weaker. Yeah, and this there's not only this process of genesis, of straightening of something, there's always process of dying, the destructive processes. We keep forgetting that they also exist, and that they take equally part in we need them to for plasticity, for changeability to take place. So so that was about potentiation more, and we talk about potentiation more, but the opposite process, which is called depression, is also to the same extent important process that take part in modification of those neuronal pathways. And some nerves work, some nerves network, they increase their performance by depressing synapses involved in cognitive tasks that have lead to mistakes and during the process of learning. This phenomenon is crucial for learning. So when we learn, we not only increase some of the synapses, but at the same time, it increases in comparison and simultaneously with depression, with decrease in other some other synapses. It's when we learn, like we do mistakes, and those synapses that are recognized as a mistake, they undergo depression. So this is very important. Not when we learn, we only create those, make some of the synapses stronger, but at the same time, it also works with as a principle on a this process is based on the principle of natural selection. So natural selection is not only some of the synapses are selected to be more to undergo potentiation, but at the same time, it's lots of them, those that were not selected, undergo depression, undergo decrease in their state. So, and it's very important, like for all of our actions, for the way our brain undergoes changes as a result of a new experience, and the way we learn. It's not only positive changes, but those destructive changes are equally important. So, as we saw, synapses are very plastic. They change very fast. They learn, and their ability to learn underlies our capability of learning something new. And also, Malabou talks about another type of the third type of brain. This is my favorite. Let's see. Yeah, reparative plasticity. It designates the brain capability of regeneration and repair. So when the trauma takes place, or some kind of disorder, brain disorder, there occur a process of reparative plasticity. This means that brain cures itself. And examples of such traumas that can occur is strokes, encephalitis, for example, and neurodegenerative disorders like Parkinson's and Alzheimer's. And the nervous system always demonstrates the plasticity after such disorders or traumas take place. The effect during this reparative process is the affected structures or functions. They try to modify themselves in order to compensate. There is compensation, cures, and the new organizational ways try to restore the normal state of the brain. So, and this type of plasticity, it's very important for Malabou and for me, because on the basis of this interpretation of reparative plasticity, Malabou will later develop her concept of destructive plasticity in her book, The Ontology of the Accident, the essay on destructive plasticity. And she would claim that, and I'm going to talk about it a lot in my class about childhood and trauma. I think it's will take place in November. Malabou talks about destructive plasticity a lot. She claims that both contemporary neuroscience and psychoanalysis, they fail to take this kind of plasticity into account. They just, well, they do, but not in the way that Malabou claims it's supposed to be considered. And it's same with psychoanalysis and same with neuroscience, because in Freud, Malabou claims there are no middle term between plasticity of gaining form, so something can gain form, and in Freud terms there is elasticity of erasure of form. So in Freud there are either destruction or gaining form, or genesis, or gaining form. And so he failed, and the same is with neuroscience. They failed to take into account the possibility of the formation of something new, of formation which is destructive formation. And for neurobiology, I saw, although it deals with transformation of identity as a result of those brain lesions with this type of plasticity, but it always talk about it, it theorizes it as a part of a healing, that it doesn't see it as a self-sufficient process. It's only something that occurred before the process of positive plasticity will take place. So in neuroscience, same as in psychoanalysis, plasticity is always positive plasticity. It doesn't take into account this whole whole dimension of destructive processes. It's present them as secondary, as something that is additional yet to the positive generative processes. And this is what Malabou tries to, her philosophy, the way she builds her philosophy on a basis of this neuroscientific conceptualization of change, of our changeability, is that she tries to show, for her it's very important to show that they don't take into account, same as psychoanalysis, they fail to take into account the destructive processes. And this is how she, I think it's very important, to something to add to neuroscience and well, the psychoanalysis probably as well. So the question for us here to consider, possible questions, are discussion point. What are the advantages and disadvantages of psychoanalytical concept of libidinal plasticity and neurobiological concept of neuronal plasticity? So as we saw, those are two ways. One is the old way and one is a new way to present a changeability of a human being. Yeah, during Freud, once we start to understand that we don't have this fate, that everything, we don't have some metaphysical dimension of our changeability, and Freud was developing his understanding of changeability of human being through his concept of libido, through his extended concept of sexuality, was trying to present to show how we formed, not only in a predetermined, biologically predetermined way, but how it depends on our interaction with environment, on our experience. And now in contemporary discourse, neuroscience present the changeability of human brain, of who we are, by developing this concept of neuronal changeability of our brain, of those neuronal pathways. But yeah, for me, and I think this is a great, how philosophy can be useful here, in my view, is by presenting this, by explaining that these destructive processes, they are same crucially important for the any changeability. They are to the same level important as generative processes, because the way it is, as you saw, the way it is conceptualized now within the neuroscience, it's something that is still in a way theological thinking, the theological thinking which sees captures only genesis, that there is this generative processes, but fails to recognize the destructive processes. Like we think in this way that something that develops has to be generated. Yeah, and there is the destructive processes we usually see within this theological thinking. We see them as the opposite of development. But even this Hobbes law is formulated in this way because it captures only positive, even if we recognize that there is this long-term depression at the same time with the long-term potentiation. It kind of fails to recognize it as a process of the same importance. Yeah, and on every stage of human, on every level of this plasticity, neuronal plasticity, we see that even if neuroscience is conceptualized in such a way that it presents almost uniquely only generative processes, like that new nerve cells are, new neurons are born in embryo brain, and new synapses are formed, and then in Hobbes law we see that the decrease, the potentiation, the synapses start to be stronger, and we keep forgetting all the time, just probably our worldview structure in this way, that we don't recognize that there is always destructive processes that are not least important, that they have to occur, and they have this powerful power of plasticity, not just by themselves, but they are a part of the process of plasticity, this destructive processes. And on our next meeting, we will take a look on some other concepts, like we'll discuss trauma, affects, and wonder, and those concepts that Malabou develops, and I also develop some of them. And in my view, they capture much better some of this destructive part, this important destructive part of the process of our changeability. And this is the connection of neuroscience and philosophy, where it can be fruitful, and precisely by showing this destructive part as equally important. And we'll also take a look on cerebrality and sexuality as something that defines a discourse of psychoanalysis, and cerebrality as Malabou's concept that she tried to conceptualize as a new type of explaining something that Freud was trying to explain through the concept of sexuality. So we can discuss something now, if you would like to. Yeah, I will unmute all of you, and if you have, you started to talk here already. Cool. Okay, I'm muting all of you. Sorry. Yeah, you can mute yourself, but just if you have questions, you can ask me, or if you have ideas, you can come out.
I posted a question.
Yeah.
I posted a question where I'm asking if how the neuronal processes, how the theory plasticity can relate to subjective experience. That is, at the point where we can make connection with philosophy and the theory of the subject. Is there any effort?
Yeah, I didn't hear it really well. Can you type your question so we can read it?
Oh, I typed it.
Okay. We can read.
This is Thomas.
Yeah. How can the neuronal processes be related to subjective experience? Here, PA has an advantage, right? Yeah. Well, it is different. It also conceptualizes the way subjective. Just in it, I think they quite most type of interpretation, like of the subjective dimension and objective dimension of those changes, they correspond. So if the subjective changes take place, like with our thinking, the process of our what we think and what we feel, the brain changes at this time, and it has objective dimension. So just two different sides of one coin, and I think those are. I think they're supposed to start to coincide in one place, because you need to analyze both. It's not enough, obviously, not enough to analyze only objective dimension, only see those changes in neurons, because if you don't add subjective dimension of it, it's just senseless, right? But at the same time, psychoanalysis here is not enough either, because it's very easy to start to be just fall in mysticism, because if you presuppose that there are no objective changes, it is just some kind of theology. So I think they need to work together, this analysis of subjective dimension and objective at the same time, because with only subjective, it's quite might be quite repressive, because it depends. The interpretation of subjective experience depends on subjective experience of those who analyze it, but still we can claim that, yeah, and it's to less extent in case of objective analysis, it depends to less extent probably on subjective experiences, the one who analyzes it. Oh, there is Megan. Yeah. Yeah, I think the neuronal process can explain subjectivity in a sense that there are billions of neurons, which once were fired together in idiosyncratic individual to each person. Yeah, I agree. Yeah, so unconscious and conscious, they both have any changes that take place in a brain, in us. And the way we change, nothing can be changed in us without objective changes taking place in our brain. And it's same with unconscious and conscious. What we define as unconscious currently in neuroscience is some structures that are just more rigid, already formed, and less plastic than, well, more plastic. Something we got used to, the way we got used to think, something that doesn't change that well. So this is unconscious. It still changes, just it's more rigid. Are these processes apoptosis or synaptic pruning, functioning merely to make necessary space for newer, healthy neurons? The benefit being at the level of individual neurons, a simple exchange also enable larger scale structure reconfiguration that increase overall parsimony of the neuronal system. Well, I prefer to. This is the problem with us, that we think in such a way that that only the genesis is important, like it's a leading process that something generates. But I think and like if there are destructive processes, they are secondary. They just make a new space, and they are like helpers. They help something dies in order to something new to appear. But when I try to change, this is, in my view, it's a theological thinking. Like there is generation. You want something to be generated, like pure creation and development. But this is the way of thinking that I'm trying to change, and I'm trying to see this very process of biological process of evolution and the principle of this natural selection. It works on like every level of our biological reality, and this process is precisely different from this process of pure creation. And to think it in a different ways mean to see the destructive processes not as secondary, not as something that just helps this main process of creation, but as a very source of not creation but formation. Yes, something that it is a formation. This destructiveness, something that dies away, destroys. It this chisel, the sculpturing. Something dies away, and this is how something is formed. This is a formation. The destruction is formation. Yeah, there is not the opposite. The formation is not opposite to destruction. But like you have a big stone and you want to make a statue out of the stone, but there is you're not a person. It just all these things that we don't need it. They die away, and the sculpture appears by itself. So this is how formation works. It's not that someone deletes those parts because for something new to appear. This is the opposite way. The destruction as destructive process of the sculpturing process. What I'm trying to think. Yes, we use. Yeah, good, you can talk to each other. Do you have any other ideas and questions? Yeah, in analogy to information tech, the brain is the hardware and it just shows physical activity. A presence, however, is the content of the data that flows between these hardware units that determines the behavior of the hardware. Yeah, probably. Like it's too hard for me to think in those terms. Oh, okay. So, what we can do, all of those discussion points, they're really wide, and I will post them in this our platform, and you can discuss them somewhere, probably as a comment to the recording of this class, or you can also, it's not necessary that you discuss those discussion points, because you can also discuss anything you think is relevant to this class and what really is interesting for you. Is there any other ideas and thoughts how about plasticity in general and psychoanalysis or neuroscience? Okay, so probably it will be more this idea of destructive processes as something that is not least, not less important than the process of the genesis. We'll understand it better on our next meeting when we'll talk about trauma and affects and wonder, because those, even if wonder is really a romantic concept, but it's destructive because it changes human being as by leaving an imprint on us, and it's quite quite a destructive process, we can say. Yeah, I think destructiveness and constructiveness of the brain is directly related to the death drive and libido. Yeah, this is a great. You should develop it. You should develop it in your blog entry, because this is a great something great to think about the forward death drive, and even to reinterpret this concept as in a more wide way, because before it was still connected to sexuality. He was trying to think it in a context of sexuality, but it's better to think it as something even more general than sexuality for human beings. Okay, great. If you don't have any more questions, we can meet next week and discuss. Maybe you will come up with some ideas. So next week it's cerebrality, sexuality, trauma, affects, and wonder. And I would like to. Yeah, I don't think we experience the generation and destruction of neurons. But has it been? We undergo the destruction of the long-term fixation and the synaptic connection is important, I think, to understand psychopathology. Yeah. it is important, just important for understanding of human being, because I claim in this my essay, which you can read, we can send you, about beautiful monsters. I claim that the main driving force of formation of human being is pathology and these destructive processes, traumas, and so there's destruction processes that underlie the formation of human being, and this destructive plasticity is a general type of plasticity, is the main, because all other types of plasticity, as we saw, we present them as generative types of plasticity in contrast to destructive plasticity. But if we see it from the other side, if we consider all those destructive elements as equal, and they are equal, it's logically to conclude that they're equal because they need to take place in order for any type of plasticity to occur. So if we think about this, the other side, the dark side of all other types of plasticity, we can claim that all of them are destructive. Yeah, and the child development, including the brain development, if you consider apoptosis, see it as a center, because we can. It should take place in order for brain to be formed. So if you consider from this point of view, from the point of view that apoptosis is central, we can claim that this is destructive plasticity. So basically, my idea is that every type of plasticity is destructive plasticity, and it's on all the levels, even on our subjective level, those psychological traumas. It's something that underlies process of trauma, of us traumatizing ourselves. Is something that underlies learning and gaining of new experience, and all the processes that we have to undergo in order to change. They might be considered destructive because new experience is traumatic, because it changes it. We call it new because it doesn't exactly correspond with something that already exists, experience that we already have. So it traumatizes us in a way. It is traumatic, and the new knowledge is traumatic because it's new, means it does not fully coincide with something that we already have, and it traumatizes us because it's new to us. It's something that we are not yet, so it differs from us, and in this way traumatizes us. Same as learning, have to do mistakes, and on a basis of those mistakes are quite traumatic process. But without this process of mistakes, of selecting something that is better than something else, without this selection, which is traumatic, the process of learning will be impossible to accomplish. Mm-hmm. Yeah, probably I will download this, upload this essay in your folder. Okay. So, do you have any more questions or ideas? Okay, then see you next week. It was nice to meet you today. I could hear you. See you next week, and yeah, thank you. And we'll discuss more destructive, dark side of plasticity and other processes. Thank you. See you. I see you.